Greetings, folks. This is tutorial number 8 in a playlist that I'm preparing called Kinematics in the 3D Experiences platform. Uh, Tutorial 8 deals with developing a slider crank mechanism, which of course, once the crank turns, makes the piston moves up and down the base. However, remember that this is beyond just making a cartoon and animation. I'm going to put some physics into it so that, for example, the speed of the crank is known, and you're going to be interrogating 3D experience to give you for example, the acceleration of the piston, etc. I also want to remind you that buried in the 3D experience platform, the kinematic solver that I'll be using is actually the CATIA is coming from the CATIA family. In other words, it's the DMU kinematics that was actually the CATIA's workbench for kinematics calculation. Of course, adjustments have been made so that the icons are new, additional functionalities have been added, etc. Now, the dimensions that I'm going to be taking are these, and I'm going to assume that the crank turns at 60 RPM and performing the simulation for a 2-second interval. These are the chapters of a textbook that I wrote back in 2016, which used the R2016 version of the 3D experience, and it was not updated. So currently I'm doing chapter 4. So this stuff is in chapter 4. Instead of revising the book, I decided to create these tutorials, which shows you the most recent uh, functionalities and um, the icon and interface of the platform. Okay, let's go ahead and make these things. I decided to make the parts, although it chews about 5-6 minutes of the tutorial, but at least you can do it all the way from the beginning. Let's start with the base. So right click, properties, right click, insert 3D part, and I'm going to call this thing base. Okay, let's give it a minute. I am in the assembly design, because you have assembly design, of course. Okay, so let me right click properties, and I'm going to change this thing to, I'll put the base here in the front, base, so that you know what it is. And then on the instance, also put a base. Instead of renaming the whole thing, I just put a prefix of base, and let's go make it. So double click on this on a convenient plane, which happens to be this plane. I will sketch a 1x1 rectangle. Okay, so yeah, so let's make this thing 1 by 1, exit, and then padded for the length of that base is 12 inches. Okay, and on this face I'm going to make a little stand or pin. The diameter of that pin, radius of it is 0.25. Yeah, 0.25 based on the drawing. Okay, exit. It doesn't matter exactly where it is, but roughly there. And then I'm going to pad it by a thickness of, by height of 0.5. 0.5. All right, good. So this takes care of the base right there. Okay, let's go and all the way to the top. Let's do the crank now. So right click, insert 3D part, and I'm going to call this thing the crank. crank. Yep. And crank here. Well, let's go make it. So double click on this on a convenient plane. Why don't I make this thing as a convenient plane? I will sketch. Okay. Uh, you can draw that crank exactly like it is, or you can use some of the features here, for example, project that circle, etc. But it's simple enough that I'm going to actually make it. You see for a second. Yeah, elongated hole. All right, so the distance, let's put some dimensions here from here to here. It is, I believe, 1. Yeah, 1. And that distance is 3.5. Okay, let's put some circles at these two ends. So a circle here, and that thing is 0.25. The same thing on the other side. Another circle there, also 0.25. Okay, exit. And now we're going to pad this thing by 0.25. So pad this thing 0.25. This is going to be the crank. Okay. We go all the way to the top. Now let's do the conrod. Okay. So right click, insert, 3D part. I'm going to call this thing conrod. Conrod. And for the instance also conrod. All right. Let's go make it. All right. Since yeah, so on that face I will sketch. Oops, let's go to the conrod 3D part. On that face I will sketch. This time, you know what? I'm going to project that. I can do exactly the same thing that was done here, but I'd rather show you some other feature if you don't know already. So if you go to sketch, project that circle. Okay. Okay, so now I do the rest of this. In fact, I can hide this if it's bothering me. Okay, there is the projection. You can see that. And I'm going to hide the guy in the back. Oops, where's the projection? Control Z. Okay, so let's do the rest of it. Another elongated thingy. There we are. Yeah, one thing I forgot to do when I made this thing, I forgot to, well, actually, no, it's okay. It doesn't matter. So this radius will actually be 0.5. It's okay. So first of all, the length of this is based on the drawing 6.5. Oops, Control Z. In there. Let's do this so that I don't get the same message. I select this, control that circle. Why don't I make them coincident so that I don't get that issue? Coincident. Okay, now I can dimension this. I'm sorry, control Z. Let me give the dimension here. That's because that control Z is not going to, that coincident is not going to do it. I'll make this thing 0.5. Yeah. Okay, now I can make this thing 6.5. Good. Let me draw another circle at that end. radius 0.25. Okay, exit, exit, and now we pad it by also 0.25. Actually, pad it by 0.25. Yeah. Okay. So let's see where is everything. So let's bring these things in the front. See what we got here. Okay, because I made a projection, there is a circle here. There is this surface that I can hide. Okay, they're sitting on top of each other. You can always use the compass to move things. So for example, this there. All right, good. Now let's go all the way to the top. The only thing that's left to do is the piston. So right click, insert, 3D part. I'm going to call this thing the piston. And here is the reference. Yeah, piston. One is the name of the part, the other one is the instance name. Piston. These are things from CATIA. Okay, so let me put this thing over there. All right, so let's go make it. Double click on a convenient plane, whatever is convenient to you. Why don't I also do the same thing? So, well, actually, I'll make a block. So it's okay. So on that plane, I will sketch a square 1 by 1. Okay, exit. Let's pad it by 1. And on that face, I will sketch. I'll sketch a circle here. And the radius of it 0.25. Exit. I could have done a multi-pad if necessary, and this length is going to be 0.75. 0.75. Okay, so all the parts are made. So what I have here is, let me go all the way to the top, quickly save everything. So what I've done here is this configuration. Now I have to put it together. So why don't I go ahead and I've got to go to the assembly first, right there. Okay, I'm in the assembly design. I'm going to fix this base. So um, uh, under the engineering connection, fix the base. Okay, so everything is going to move. That's clicks. So let me place the crank in there. So I'm going to create a revolute joint. I just noticed something here. This thing, actually, I wanted it to be, I didn't want this thing to be a hole here. I wanted this thing to be a pin. So let me go ahead. I forgot about that. That's okay. So let me go here to this part, which was the connecting rod. I made a mistake. Connecting rod. Let me go to that part. Okay. And to that sketch. To that sketch. I completely forgot about that. So where is that sketch? It was right here. The sketch. Okay. Uh, this thing I want to delete. So exit. Okay. Now on that face, I will sketch. Okay. Why don't I project that circle? It's easier. project. I'm not sure on that fail. Let me exit. Actually, let me exit. Sometimes if you do it the long way, it's better. So on that face, I will sketch. I'm going to project. I'm going to project that circle. Okay. Yeah. Okay. Oh, it got projected. I'm not sure. Yeah, it was there. And then pad it. Something that I exit this and then pad it by 0.5. I wasted some time here, but that's fine. Go all the way to the top. Okay, let's put the crank in there first of all. So what I'm going to do is I go to engineering connection. That's a revolute joint. So revolute. Okay. So the different the template. So I'm going to be using for revolute. I'm going to be using this template. So I need axis and axis, this axis and that axis. Oops, cancel. The order, the first one that you pick will be moved. So let me do it the other way around. So try it again. Revolute. Okay. Using this axis and that axis. Okay. And then plane. I'm going to do this plane, and I can use this plane or the one in the back of it. Okay. I'm going to flip the direction though. Okay, that's good. And finally, because this is going to be controlled, the RPM is going to be specified later on here. I need to specify the two planes which are actually determine the position of the revolute. So let me actually not, I don't want to hinge. Either. Well, that's the one that I wanted actually. This is the one that I wanted. Yeah. So plane and plane. So I will do, for example, the angle between this plane and which one is that? The plane of this is a crank. Is that right? This was the crank, which was the second thing that I made. And let me see where is the coordinate system? And not XY. Let's check. Oh, right there. The angle between these two. That's fine. And then we say OK. I don't want to do any contact calculation. Now, let me actually move this thing, rotate this thing a little bit. So I'm going to rotate it. Where's the manipulate? I'm going to rotate about this axis. Yeah, and then say OK. All right, let's put this connecting rod in there. So another revolute. Okay, between which one is the template? I use a template. The one that I want to use is same one that I did before. This one. Actually, where was it? Yeah. So axis, and axis, and then this plane and that plane. I'm going to flip the direction. Okay, good. And yeah, and we don't have to control this thing because this is going to let me delete this. We don't want that. That's good. So that's going to be a revolute joint. Say okay. Why don't we place the piston on there? So We're going to do a prismatic one. Prismatic one. Which one was the template? I'm going to be using, I don't know, maybe that one. So line and line, plane and plane, and then now we don't need to control this thing, but that's okay. So we go here between this and that, and this plane and that plane, okay. And that's okay. I don't need this thing. That's good. Now let me move this thing to the right side here. So translate it along this direction. You can see that. Okay, so this is going to be a prismatic joint, and now I need a cylindrical between this and this, or a revolute or a cylindrical. It really does. I'll use a cylindrical. So cylindrical between the template. So I'll use that one. So between this axis and that axis, and I don't need to control these things. So I do that, and I don't need this either. Can I update? Okay, good, good. So this is fine. Let me go and check something. Okay, so I go here on the manipulate. We're gonna rotate. Constraints being checked, so I'm gonna rotate about this. See that? This one says that okay, keep the constraints in active. That's what I want. So it is doing what it's supposed to. Okay, good, good. We're done. So essentially, we have created the assembly and all the necessary constraint, and now we're going to go to right here, mechanical system design. Let's create our mechanism. Okay, let's create the stuff. So notice that there's a green check mark here, which means that it should work. Okay, good. So let's try it. Here is the mechanism player. Let's go ahead and check it. I don't anticipate any problems. You can see that. Okay, now you might say, well, this is going through that. Don't worry about it. I can go and actually make this length, this thing, make it, instead of padding it all the way to the 0.5, I'll make it smaller so it looks nicer. Let me actually do that for you. So let me go ahead to, this was the base, I believe. So we go to the base, 3D part, that thing. Instead of padding it by 0.5, I'll make it 0.25, and then there won't be any essentially. And here, also here, okay, so that's good. This is done. Let's go to this. That was the connecting rod. The con rod was here. Remember that last part that I made? Also make this thing 0.25. It just looks nicer, that's all. Okay, good. So we go all the way to the top. Okay, let's try it now. It's nice and clean, as you see. Oh, not there. They don't go through each other. Everything looks good. Okay, very good. So reset. Okay, good. Now we're going to put the physics into it. So the question is, how do we do this? Let me minimize these, collapse these. So now we're going to go to mechanical systems experience. Say okay. It's going to take that mechanism. Right, good. Okay. So since I'm going to specify the speed of the Revolut basically, so I'm going to go to log citation. The command is this command. Remember I made it Revolut here, and you click on this f of x. It says okay, that angle equal to. So I'm going to type 60 turn underscore min 60 rpm, or you can put down 360 degrees underscore second. It's entirely up to you. Times time. As I said, the alternative would be write down, for example, 360 deg underscore s times time. Okay, and then we say okay, and then we say okay. All right, and now we create a kinematic scenario. This is the excitation that I use. For the time, I'm going to use 2 seconds, and for the time step, I'll use 0.1. Otherwise, it's going to be very jagged. Okay, so what I'm going to show you now is this is not going to be a cartoon. I'm going to simulate this thing for 2 seconds, right? Let's go ahead and do that. Good. I think that was too fast, so maybe I should go back and change this. Go back to scenario. Go back here, the one that we created. Let's check this thing and make it 0.01. Okay, now do it. Good. You can, of course, play the animation. Play it. There's a physics here. The speed of that crank is actually 60 RPM. It's not just, some cartoon that I made. So let me stop this thing. Now, suppose you want to plot the velocity of this point. So what we're going to do is we're going to say, okay, go back to our mechanism right there. Probe. Oh, actually, I'm sorry. Go back to scenario. There's a probe here. Go back to scenario, double click on this line, scenario 1, so that you go into scenario. And there's a probe somewhere. Here's a probe, speed and acceleration probe. So I select that point, for example, if I want this point, and then we say okay. And then we see, if we try to plot things now, we won't have to run it. So if you go back to the results, results here, and if you click on this scenario view, notice that it doesn't give the stuff that I want. So say close that, go back to scenario. You have to simulate it. Basically, you have to compute, and now when it sends you to results, you have the option of selecting stuff. So for example, let's say that I want the velocity of that point, velocity and acceleration of that point. So let me deselect everything. Linear velocity, if I put this, it's going to be the magnitude of it. Otherwise, you have to select a component in the, what is that, x direction, I suppose. And the acceleration, if you want linear acceleration, this is the magnitude. And then if you click on this, you get both. As a matter of fact, let's go back here. Let's say, just show me the velocity. You uncheck that, just show me the velocity. This is the plot of the velocity. And if you want the acceleration, this is the plot of the acceleration. Okay, now it gives you also the tables here. And it is possible to save some stuff. So if you go back to this plot, I don't see any option of saving here, unfortunately. So I suppose you have to screen capture, or you can create a table, send that to Excel, or do some other thing. I don't see an option of saving this stuff. Now, let me close this thing. Suppose you want to know what is the path of this, the path of, for example, the middle point of this connecting rod. So I need a point here, right? So let me see if I can actually do it like this. So here's geometric trace path. See, if I had a point, I could go and select that point, okay? But I don't have a point here, and it won't let me do that. See that? Cancel that. Let me go back to this crank. Let me go back to that crank. Not the crank, connecting rod. That part. Okay, and create a point on a, say, on a surface, on this surface. Okay, this one, and then say okay. Now I go back to my kinematics, back to my results. Let's see if we can select this point now. If not, then we're going to run it. Yeah. This point, and then say okay, and there we are. So that point goes through this. If I do a copy and paste here, there we are. So if you go to your kinematics and do a, for example, a animation, that point will follow this path. Let's do one more thing. Suppose you want to see the volume swept by this, let's say, by this connecting rod, by this, well, by the connecting rod. Okay, so I'm going to click on swept volume and say okay. The thing is that it gives you, oh, I should have picked something. I should have picked it. Sorry. Let me delete that. Try it again. Swept volume. Let's say this. Okay, and then we say okay. Let me fit it. Maybe is it somewhere here? Oh, it was there. Okay. The thing is that it gives you everything, but if I don't want everything, you have to just ask for that specific thing that you want to. So let me actually go ahead and do the following. Let me copy this back there and paste with here. Uh, you may have to go to your original thingy. Okay, paste. Good. The only thing is that if I don't want everything, because that selects all the stuff. So let me go ahead here to the kinematics, and under this swept volume, the first one is not what I wanted, so I'm going to delete it. Second one, double click on it, and let me see. It allows you to pick stuff, or click on this. You see that? Click on this and say, just show me, for example, the, I don't know, the the piston or the crank. Just show me the part. Let me remove the piston. Okay. So when I created these things, I could have selected different different stuff, and yeah, it's kind of tricky here. It's easier when you do it in CATIA, but the 3D experience a little bit messy when it comes to this. Anyway, that takes care of our tutorial.